Have you ever played a game of moving statues? The rules of the game are simple. The statues want to reach the curator as fast as they can. When the curator's back is to the statues, they can move freely. As soon as the curator turns back around, they immediately stop moving. If the statue is caught moving by the curator, the statue is sent back to the start. Once the statues reach the curator, the game ends. A game of moving statues is kind of like the Heisenberg Uncertainty Principle. The Heisenberg Uncertainty Principle, coined by physicist Werner Heisenberg in 1927, shows us how measurement affects the system being observed. Heisenberg showed us that in quantum mechanics, it is impossible to measure both position x and momentum p simultaneously without a certain level of uncertainty. The uncertainties of momentum and position will never multiply to less than Planck's constant h over 4 times pi. When the curator's back is turned to the statues, the curator can hear the footsteps of the statues. A good curator might even be able to use this to estimate how fast the statues are moving. As soon as the curator turns back around, though, the statues immediately stop moving. Because of the way the curator is observing the statues, while they can see exactly where those statues are in space, they can't tell how fast they were moving just a moment before. The best statues can take advantage of this to win. But why does this happen in quantum mechanics? We are able to measure the position of a subatomic particle like an electron by bouncing light waves off of it. This is an amazing way to measure the position of an electron, but it can drastically alter its momentum. Every time we bounce a photon off of an electron, the photon transfers some of its momentum to the electron. The electron is so small that this drastically alters the momentum and makes any measurements extremely imprecise. The faster and shorter the light waves are, the more sure we can be of the electron's position, but the more drastically the momentum is altered. The larger and slower the light waves are, the less drastically the momentum is altered, but also the less sure we can be of the position of the electron, or even that we can hit the electron at the speeds it's moving. This happens in the macro world too, but the effect of a photon hitting, say, a basketball are so small that we can usually just ignore it. So what do? There's no way to completely get rid of the uncertainty, but scientists are working to make it as small as possible. Some of the strongest proposed solutions so far include changing the environment to slow down the subatomic particles' movement, and changing the ways in which we measure them. Now you know the Heisenberg Uncertainty Principle, and how to win moving statues.